Sustainability, it is indeed an important goal, and most of you are planning to go on this path shortly. I'll give a few more seconds to all of you to finish this little poll before we continue to the webinar. Thank you very much for answering the question on the chat, but if you could also select the right option on the main screen and therefore participate in the polling, we would very much appreciate it. Okay, I think that this will be enough time for everybody to answer this quick question. So I'll be ending the voting now. As we all know, this is second in a series of webinars from Dow on sustainable packaging solutions. Sustainable packaging has increasingly become an important direction in plastics manufacturing, with Asia-Pacific being a potentially major market. Dow has recently taken an aggressive step forward with its new 2025 sustainability goals to reduce greenhouse gas emissions, stop plastic waste, and drive toward a circular economy. Specifically, one of the goals would be to help close the loop by having 100 of its products sold into packaging applications that would be reusable or recyclable by 2035. Designed for recyclability, here's a look at Dow's INNATE TF Polyethylene Resin for Tender Frame Biaxial Orientation.
Introducing a new member of the family. The answer to many packaging problems. Despite being widely employed in many packaging applications, conventional PE has its limitations. It's hazy. It obstructs customers' appreciation of the product. It's flimsy. It's soft to touch but susceptible to bends and scratches. It's fragile. It leaves the products vulnerable to impact. At Dow Packaging and Specialty Plastics Lab in Asia Pacific, our packaging scientists have made the constraints of conventional packaging materials a thing of the past. One of Dow's newest innovations, Tender Frame Biaxially Oriented Polyethylene, TF-BOPE. The side-by-side comparison tests of TF-BOPE against traditional PE were insightful. In the dart test, all the weights in the lab were still insufficient to drive the drop hammer through the TF-BOPE film. The same was achieved in a slow puncture test, even if we chose TF-BOPE film thinner than that of a conventional PE. In the drop test, PE bags broke easily when dropped from the height of a person, while TF-BOPE bags remained intact, sustaining the impact of falling from the roof of the lab. In the haze test, we stacked over 30 pieces of plastic films over a special logo board. With PE, visibility of the logo on the board gets hazy and increasingly blurry. With TF-BOPE, however, it allows the logo to remain transparent until the end of the experiment. The glossy shine of TF-BOPE adds appeal to your products. Conventional PE bags can be hard to tear, causing unnecessary frustration and inconvenience at times. TF-BOPE, on the other hand, is easy to tear, like a piece of thin paper. Conventional PE is often blended with other polymers to achieve a material that can capture true-to-design color prints on packaging, but this makes it hard to recycle. TF-BOPE is not only directly printable, but its 100% PE structure means it can be recycled in full. We also tested the stiffness of two stand-up pouches. One topples easily, and the other stands firm. From the test results, we measured twice the stiffness in the TF-BOPE pouch. In comparison to other polymers, TF-BOPE demonstrates the most balanced performance package. it enables polymer substitution, a fully recyclable structure, convenience of usage, and better protection. With this new innovation, BOPE and SP hopes to create new possibilities for you, your products, and your brand.
Made you interested in today's webinar even more. Today we have two presenters from Dow. Our first presenter, Mr. Jason Yu, is Market Development Manager for Southeast Asia, Australia and New Zealand territories of Dow Packaging and Specialty Plastics. He has more than 5 years of experience at Dow and a keen understanding of the flexible packaging market dynamics in Southeast Asia and Australia and New Zealand. His primary focus is in the development of food packaging technology and accelerating the shift toward a more sustainable packaging ecosystem in the area. He is joined by Dr. Yi Wo-Ike, the Senior Technical Service and Development Specialist at Dow. He has more than 7 years of experience in the technical field in Asia and regularly collaborates with regional customers to develop and improve their flexible packaging in applications such as food and industrial packaging. So I believe we have two great experts today, and now let's listen to their presentations.
Good morning and welcome everyone. Thank you for taking the time out of your busy schedules today to listen to us this morning about what we see as the future of sustainable packaging. My name is Jason. I am the Market Development Manager for Southeast Asia, focusing primarily on the food and specialty applications. And I am joined today by my colleague, Dr. Yi, Senior Technical Service and Development Specialist for Asia Pacific. And today we hope to give you more information about advancements in polyethylene technology and how this lends itself to a more sustainable packaging. I would like to start off with some of the megatrends that we're seeing today in the flexible packaging industry. The growth of single-serve packaging formats requires more features focusing on customer convenience, with ease of use being a key concern, and features such as easy-to-open packaging, as well as having differentiated packaging with the looks and feel being key features for this segment. Productivity and efficiency continues to be a key concern for film manufacturers and converters, with ease of processing as well as being able to run their converting lines at higher speeds being key focuses for converters and film producers. Packaging reliability is expected to remain at the highest levels with lower failure rates and more reliable primary and secondary packaging, ensuring longer shelf lives for products leading to lower food waste. Finally, sustainability is an increasing concern globally across the entire spectrum of manufacturers, brand owners, and end customers. With regards to flexible packaging, we see this in three different facets. Conducting effective life cycle analysis, we believe, is a key step in identifying where the best solutions are for the short term and the long term. And in conjunction with optimizing the amount of packaging material being used, a key part of our multi-step sustainability plan is to provide resins that enable the final package to be recycled easier. In recent years, plastic waste, specifically waste that ends up in the environment, has become an increasingly bigger issue. There are no shortage of articles in the media nowadays that brings emphasis onto this issue, and it creates a very negative perception of plastic to the general public. Plastic, however, in many ways is an irreplaceable part of our current economy and brings significant benefits and convenience to our daily lives, some of which have especially been highlighted during the current COVID situation. The solution that is increasingly being requested by consumers as well as producers are plastics that can be easily recycled and reintroduced into the production cycle. At Dow, we have recently announced a new set of sustainability targets that builds upon our 2025 sustainability goals. These goals combine three main areas: protecting the climate, stop the waste, and to close the loop, further re-emphasizing our commitment to reduce and eventually to eliminate plastic waste. Our vision of doing so is by facilitating the growth of a circular economy. Doing so requires building impactful relationships with like-minded companies and to provide real circular solutions to the industry. On top of other solutions such as PCR resins, BOPE, and our retained compatibilizers, one of the solutions that we are proud to present to you today, after close to a decade of research and development, is our new line of INNATE TF resins, a line that we launched last year and which enables recycling, which was previously not possible. The current generation of flexible packaging faces several significant challenges when it comes to recycling. Most multi-laminate structures that are currently in the market are not recyclable in the current recycling streams, primarily due to the number of different materials such as aluminium, PET, and nylon, as well as other substrates that make up the packaging structure. Additionally, the current generation of mono-material structures that are recyclable tend to have significant drawbacks, such as being more fragile, more flimsy, and are generally hazier with poorer optics. With our new resin technology and utilizing a Tender Frame Biaxial process, we are able to move past the traditional barriers of polyethylene performance with better all-round performance in recyclability, toughness, clarity, stiffness, and heat seal performance, and is comparable to other resin types such as nylon and PET that was previously not possible. Looking within the polyethylene space, in comparison to a traditional blown or MDO PE, our new films provide significant improvements in performance, especially in the optics and toughness metrics. I would now like to hand over to my colleague Dr. Yi to give a more in-depth explanation of the mechanics of how this works, as well as to provide some case studies that we have prepared. Dr. Yi, please.
Thank you, Jason, for providing a comprehensive introduction with focus on market needs in terms of sustainable packaging, as well as touching base on some performance factors of Tender Frame BOPE when compared to other oriented substrates commercially available in the market. Before we look deeper into the performance of Tender Frame BOPE, let us understand more in terms of the biaxial process to make such films. Tender Frame BOPE, like BOPP, which is biaxially oriented polypropylene in short, as well as BOPA, which is biaxially oriented polyamide, are films that are stretched in both machine and transverse directions sequentially. The resin is first cast into a film, heated by heated rollers, and stretched in the machine direction in a magnitude around 4 to 5 times. It is then further stretched in a transverse direction by a magnitude of 8 to 9 times to achieve the desired thickness. Due to the orientation imparted by such enormous stretching, unique performance can be observed in Tender Frame BOPE film. However, to stretch at such extreme magnitudes, the stability of the film during stretching becomes increasingly challenging, in which a normal polyethylene resin cannot be used due to the narrow operation window for such extreme orientation process. With the development of XUS 59910.08 polyethylene resin, which is basically a 1.7 mi, density of 0.926, stable but axially stretching of P is now possible. This resin is specifically designed from the ground up, using Dow's proprietary solution process, allowing stable orientation to be conducted on an industrial BOPP line with a broader operational window. With such orientation magnitude in both machine and transverse direction, Tender Frame BOPE will exhibit the following properties such as excellent toughness, optics, and even stiffness. And one of the key aspects of the films produced is a narrow gauge variation. Next, let's touch base into more details of the performance aspects of Tender Frame BOPE, reaching new heights in packaging performance. One of the hallmarks of Tender Frame BOPE is toughness, So let's compare the performance of Tender Frame BOPE to another tough film commonly found in the marketplace, BOPA. Do take note that the yellow line represents Tender Frame BOPE while the red line represents BOPA. Experts who are skilled in the art of flexible packaging will vouch for the mechanical performance of BOPA, but when you put the spider chart and compare vis to vis, only the ultimate tensile load is better than the Tender Frame BOPE, while optical performance is marginally better. This is an important thing to take note, as polyethylene, a traditionally much mechanically inferior polymer when compared to polyamides, can be made so tough via the Tender Frame Orientation process. One may argue that the comparison is not fair, due to BOPE being 25 microns, and we are comparing to just a 15 micron BOPA film. However, as we are comparing commercially available films in the market, in which Tender Frame BOPE film has the opportunity to create monomaterial structures, making the package more recyclable than BOPA-based packaging. This gives rise to unique packaging development opportunities to meet your end user sustainability goals by making the primary packaging more recyclable. With such unique performance, where Tender Frame BOPE can match BOPA in terms of the impact, empty tear resistance, puncture force, as well as pinhole resistance, this truly can open the door to unique application development in support of sustainable packaging without the fear that the developed package may fail prematurely. To have a fairer comparison, let us compare the mechanical performance of Tender Frame BOPE versus BOPA when laminated to a 80 micron PE sealant web. By and large, by comparing the film itself will not be a practical way to assess the performance in real-life scenarios, as normally such films are laminated to a polyethylene sealant web. Thus, we proceed to laminate the 50 micron as well as the 20 micron Tender Frame BOPE to the same PE sealant film to have a more realistic comparison under real-life conditions. Again, we can clearly see that apart from maximum tensile stress in which the BOPA laminate can exhibit better performance, the rest of the mechanical performance such as dart drop impact, puncture energy of both Tender Frame BOPE and BOPA laminates are very similar. Tender Frame BOPE laminates do exhibit slightly higher tensile strain, but this can be easily overcome by unique formulation design of the PE lamination film. Next, let's take a closer look at the comparison between BOPA and Tender Frame BOPE film to compare them in terms of absolute performance. The first detailed look into the performance of Tender Frame BOPE versus BOPA is the optical performance. Do take note that the lighter shade of green corresponds to Tender Frame BOPE while the darker shade corresponds to BOPA. You can immediately realize that TF-BOPE is more transparent, with better clarity as seen in the left as well as the middle bar chart. In terms of gloss, both films exhibit comparable gloss. This allows Tender Frame BOPE to replace BOPA as the print substrate for content that doesn't require significant oxygen barrier performance, which will be shared later in one of the case studies. The same trend can be observed for other properties as seen on the next slide. In the area of toughness, again, you can clearly observe that in terms of dart drop impact, which is the bar chart on the left, Tender Frame BOPE's performance is very similar to BOPA. The same goes for the puncture load required to puncture the film on the bar chart to the right. When we compare the tear resistance, which is the bar chart in the center, it can be clearly observed on the advantageous performance of Tender Frame BOPE as compared to BOPA. Apologies for that. With the comparison toughness indicators data, all of this do add up, meaning to say Tender Frame BOPE has the potential to replace BOPA in applications that doesn't require higher barrier performance, where BOPA is primarily used to improve toughness of the overall flexible packaging. Next, let's look at the tensile performance of both films on the next slide. For both charts, where the left chart shows maximum tensile load in the machine direction, while the chart on the right shows the same in the transverse direction. Although BOPA demonstrates around 28% tougher tensile maximum loading in the machine direction, Tender Frame BOPE exhibits a 35% improvement in tensile maximum loading in the transverse direction. As a whole, Tender Frame BOPE has again demonstrated that it can withstand better tensile load, especially in terms of two-dimensional space, allowing Tender Frame BOPE to have the potential to replace BOPA. Pinhole resistance of the film is another property in flexible packaging where it will impact mechanical performance, aesthetics, as well as barrier performance of the overall flexible package. Thus, efforts were made to understand the pinhole resistance of Tender Frame BOPE versus BOPA. It can be clearly seen that Tender Frame BOPE is able to withstand more flexing before pinholes appear on the film, where it can actually withstand 13,500 flexings compared to just 5,400 flexing for BOPA. Thus, from all the results we have seen so far, it clearly demonstrates the toughness and optical performance of Tender Frame BOPE. With Tender Frame BOPE, it will allow packaging designers more design freedom and the ability to replace certain commonly used substrates to achieve a fully recyclable mono-material PE package. Thus, to sum up, it can be seen that Tender Frame BOPE is able to replace BOPA due to its unique performance, and this also paves the way for potential material substitution for BOPP as well as BOPET. And all these substrates are common substrates used in flexible packaging today. Additionally, as illustrated by the performance comparisons highlighted earlier, with the toughness of Tender Frame BOPE, unique combinations can be created to enhance superior protection by combining BOPA with Tender Frame BOPE using dry lamination, in which Tender Frame BOPE becomes a lamination film as it is also sealable. Let's go to the third point, where uniquely easy tab performance of Tender Frame BOPE film allows the opening for packaging designers to create functionalities which help to improve the ease of convenience for consumers. Coupled with the toughness of Tender Frame BOPE, as explained earlier, sustainable packaging solutions are opened up like monomaterial pouches, utilizing Tender Frame BOPE as the print substrate. By replacing BOPA instead of pouches, more recyclable pouches are now achievable for contents that doesn't require the barrier performance properties of polyamides. The unique performance also extends to the use of Tender Frame BOPE in label films. All these possibilities are now possible, and you're definitely invited to work together with Dow to build a more sustainable future with Tender Frame BOPE to create more recyclable flexible packages. Next, let's take a look on the practical case studies in which Tender Frame BOPE is able to demonstrate its unique performance and cement its place as a preferred solution for sustainable packaging moving forward. First, let's take a look at this particular case study, which is the use of Tender Frame BOPE to replace BOPA for form fill seal pouches, FFS in short. As you can see from the bottom left, the materials used for lamination is a PE lamination film of 80 microns laminated to either a Tender Frame BOPE or BOPA, which is a print substrate. And we'll compare the performance of the laminated films. You can clearly observe that the only performance factor lower than BOPA-based laminates is the ultimate tensile stress in the empty direction. Do take note that this will not significantly impact the performance of the pouch, and in fact, the tensile strain for TF-BOPE based laminates is much lower than BOPA laminates. This will prevent undesirable elongation issues, which may result in delamination and other related problems. Additionally, other toughness indicators such as puncture, as well as that drop impact performance are very similar for both BOPA and Tender Frame BOPE laminates. These results are extremely encouraging, and contents that can be targeted include, but not limited to, things like dry detergent powder, frozen food, snack food, sugar, salt, and many other contents. The additional advantage of Tender Frame BOPE based PE laminates is that it is a 100% mono material structure and will be the easiest to recycle, and this will assist your end user to achieve their sustainability goals. There will definitely be questions on how to seal such laminates, as mono material structures have a very narrow seal window to achieve a good quality seal, especially at high speeds. Before we touch on this, allow me to show a video demonstrating Dow's know-how on as well as technology at play for VFS pouch making. Now, does the picture from the top left indicates poor sealing? The answer is no, because Dow has spent tremendous efforts in understanding the sealing process as well as from the machinery point of view in utilizing our resins to achieve good machinability of the films in the hardware as well as understanding the laminates. So do come back to us and connect to our technical or sales representatives to see how our experts can assist you. Let's take a look at the second case study, which is the fabrication of a 100% polyethylene stand-up pouch, SUP in short. This work utilizes Tender Frame BOPE to replace BOPET as the print replacement substrate. For this case study, the Tender Frame BOPE is laminated to a 120 micron PE lamination film. And if you're looking from the SUP performance aspect, some of the key performance related to SUPs are like the drop test from certain heights in which the SUP does not leak or burst, and of course the standability of the pouch. Now you can clearly see from the picture on the left that the standability of the pouch or the SUP is not significantly affected when BOPET is replaced by Tender Frame BOPE. Additionally, by replacing BOPET with Tender Frame BOPE, we can achieve good performance, such as puncture force at about 140 newtons, as well as a depth drop impact of 676 grams. With such figures, you can clearly see that Dow's solution utilizing Tender Frame BOPE as the print substrate can help to pass the single SUP drop test. From 2 meters, 6 sides, meaning the same pouch is dropped 6 times and it doesn't leak or burst. And these pouches are made at a speed of 120 packs per minute, which is a 1 liter SUP single lane configuration. And this is a breakthrough. Now this breakthrough will allow many new possibilities in application development in SUP format for varying content which does not require high barrier requirements. Similarly to the previous case study, such development allows you to meet your end user's commitment to sustainability goals and create a fully recyclable SUP. Do come back to us, either your technical or sales counterpart, and see how Dow can assist you to develop from the material standpoint or even advice on the hardware standpoint, as Dow has spent enormous efforts to understand and improve the process of sealing for mono material packages. The next case study demonstrates the use of Tender Frame BOPE to replace BOPA in a 3-ply structure. which the incumbent is actually a BOPT film laminated to a BOPA film and finally to a PE sealant wrap. Now, due to the toughness of BOPA, some structures like this is inevitable if the brand owner or end user wants to achieve high standards for pop survivability, especially during transportation. Leaks or burst pouches can prove costly to the brand owner or end user. This is even more critical if the SUPs need to experience lower ambient temperatures due to transportation needs. Utilizing the toughness of Tender Frame BOPE films, we can replace BOPA in the 3-ply structure and still maintain the toughness of the SUP. This is clearly evident in the bar chart on the bottom left, where the lighter green bar, which is the PET Tender Frame BOP laminate, is tougher than the PET BOPA laminate. Additionally, the drop test in which the SUP do not burst when dropped from a certain height is a key performance indicator as mentioned earlier. Our results show that the PET Tender Frame BOP laminate SUP can survive a 1.5 meter drop and even survive a 1 meter drop height when they are packed in a box at both room at low temperatures. Impressive compressive test results were also achieved, in which the fabricated SUP can survive for 1 minute under 150 kg of compressive forces. This clearly demonstrates the toughness of Tender Frame BOPE and show the world that it can potentially replace BOPA. Do take note that although replacement can occur, we will still need to take note of the barrier requirements of the contents in the SUPs, as BOPA also imparts decent oxygen and water vapor transmission rate, WVTR in short, generally good barrier performance of the overall package. Thus, such replacement of BOPA has to be considered, and contents such as detergent, edible oil, pet food, or even rice packaging, which doesn't require high oxygen barrier, can be considered for replacing the BOPA used in this big packaging, and definitely utilizing Tender Frame BOPE for its unique performance and toughness. The last case study will be utilizing Tender Frame BOPE for label film applications. For such applications, we mainly focus on 3 main performance indicators, like 1. Conformability to shape with little wrinkles or no wrinkles. 2. The optical performance, which mainly consists of gloss and transparency. And lastly, suitable stiffness for machinability. Now, from the chart on the left, you can clearly see that the Tender Frame BOPE label is a good balance of clarity as well as conformability. Now, BOPP can be extremely clear, but it may not conform well with some wrinkling issues due to its stiffness. Blown PE, on the other hand, can conform to shapes very well, but it is not as clear as BOPP. Thus, having the best balance allows the end user to have the best quality label to meet their performance requirements. You can also see that Tender Frame BOPE may not be the clearest when compared to BOPP from the chart in the middle with a value of 3.7 versus 2 in haze values, but it is stiff enough for machinability and conform to surface very well. And this allows it to escape the drawbacks of BOPP. With this, I will now invite Jason back on stage to summarize what we have shared over the last 20 minutes. Jason, please.
Thank you, Dr. Yi, for your very detailed explanation. As you can see, this new technology pushes the traditional limits of PE performance with improvements to toughness and clarity. In our case studies, we have demonstrated how INNATE TF is now a viable replacement for other substrates and is a powerful enabler for a new generation of all PE packaging that are not only fully recyclable, but also without compromising on the stringent packaging performance standards that your customers expect. With this new solution, we hope to further contribute to building a circular economy and thus bringing us one step closer to closing the loop on plastic waste. Lastly, if you're interested on starting developments on these new technologies, I would like to hand over back to my colleague Dr. Yi to give you an introduction to our PAC Studios initiative. Dr. Yi, please.
Thank you, Jason. Now, PAC Studios is an innovation initiative launched by Dow that aims to connect all stakeholders across the value chain, such as retailers, machinery suppliers, converters, and even brand owners, to come together and work together. This will enable the acceleration of commercialization and bring innovation out to the market faster. Dow, being a material science company and a raw material supplier, we have the technical knowledge to advise stakeholders across the whole value chain on the performance of our products with access to Dow's engineers and scientists. And by putting substantial investment into PAC Studios, we hope to assist all stakeholders in innovation application development, in which there are three key important takeaways. Now, PAC Studios hope to collaborate, innovate, and accelerate innovation, as well as the commercialization, to allow more market space capture with our innovative solutions fulfilling brand owner or end user needs. Now, let us see a short video for more details on the PAC Studios concept.
Are you ready to collaborate with packaging experts? Conceptualize your next package design and get it to market faster? If the answer is yes, then Dow invites you to experience PAC Studios. What is PAC Studios? A new concept, a new mindset, a new collaborative process for bringing people together from across the packaging value chain to achieve common goals. PAC Studios enables the collaborative development of better packaging by accessing a global network of packaging experts, equipment, and capabilities. The result is faster commercialization of new packaging. Wherever you are, PAC Studios is ready to connect you to a network of experts from Dow and the packaging industry around the world. PAC Studios is a new paradigm for collaboration, from any office or laptop, or from one of the specially equipped collaboration rooms featured in one of our PAC Studios geographically based centers. Customers can access information and engage in conversations that inspire innovation. This unparalleled global network includes equipment manufacturers, package designers and prototyping specialists, academics, technicians and scientists, converters, and brand owners. PAC Studios brings them all together and puts their knowledge to work for you. Everyone wants to collaborate, but PAC Studios opens up a virtual who's who potential collaborators to your next project. The right expert to not only answer the question, but to help develop the right solution. Focusing all of this knowledge and inspiration into a marketable application is a key benefit of engaging PAC Studios. Customers can leverage Dow's brand product portfolio, commercial scale production facilities, physical and analytical properties labs, application testing equipment, sensory science capabilities, and much more, all in a collaborative environment to help accelerate the development of innovative packaging solutions. PAC Studios' application fabrication facilities alleviates the need for converters or brand owners to shut down their own production lines to test new ideas, offering cost efficiencies at both ends of the production spectrum. 4 regional technology hubs, plus many other specialty centers, create a sum greater than its parts, enabling teamwork across disciplines and throughout the value chain to accelerate packaging development success. So let Dow put the power of PAC Studios behind your next packaging project. Contact your Dow sales professional, your technical service and development representative, or visit the PAC Studios website to learn more. Collaborate, innovate, accelerate. PAC Studios from Dow.
I hope that the video allows you to understand the concept of PAC Studios better. In Asia Pacific, Dow has invested heavily in 3 PAC Studios, namely PAC Studios Shanghai, Singapore, and Mumbai, with PAC Studios Singapore providing assistance to application development for Dow's customers in Southeast Asia, including Australia and New Zealand. In order to accelerate innovation and commercialization for our customers, Dow has set up laboratories with testing capabilities and even film fabrication facilities, as you can see on the top right corner. Pouch baking capabilities have also been incorporated to assist our customers. Unique testing capabilities have also been set up in PAC Studios, such as the high-speed camera capturing system detailing the drop test, of a Tender Frame BOPE SUP. So you can see the video. And when we compare it to a BOPA based SUP, in which it bursts. So this clearly again demonstrates the strength of Tender Frame BOPE based SUPs in supporting your end users' goals in terms of sustainability, as well as not sacrificing performance, especially the drop test. Ending off are collaboration rooms, and of course these collaboration rooms, right, are for discussion with stakeholders across the value chain, and you are able to draw references of different types of packaging painstakingly sourced across Southeast Asia on display in the collaboration room. We invite you to use these facilities as well as make full use of Singapore PAC Studios for your application development needs. Last but not least, PAC Studios is not about Shanghai, Singapore, or Mumbai. With PAC Studios being set up across the globe, Dow will definitely have the right assets or resources anywhere in the world to assist you in your application development. I am looking forward to meet you at Singapore PAC Studios and see how Dow's technology can assist you to meet your end user needs and push innovative packaging into the market space earlier. Thank you.
Thank you very much, Dr. E, for this insightful presentation. Now, before we will go to the open floor of Q&A, we have another quick question for you to let us know what would be your primary concern with an all-PE packaging structure. On the main screen, you can see that polling right now. You can scroll down. There are 5 options to choose from. So please let us quickly know so our experts could contact you later and address your concerns. It would seem that the barrier properties is a very important issue, but I'm sure that all of those are of a great concern. So let's give everybody a few more seconds. If somebody tuned out and was checking some other elements on your computer, please come back to the webinar room right now and let us know what would be your primary concern with an all-PE packaging structure. Mr. Harish Bishid, thank you for this answer. Did you also select the option on the screen and submit your vote? Okay, I think that would be enough time for all the participants to vote. So if any of you still haven't voted, please quickly click in right now. And meanwhile, I would like to, again, thank you all for participating in this poll. And I would like to, I hope that you all learned from today's presentations. And I will be opening the floor now for the Q&A with our experts. So Dr. E, Mr. Jason, if you could please take the floor and answer some of those many, many questions that our very engaged audience asked. Hello, Mr. Jason, Dr. E.
Maybe they're looking for questions to answer.
From the many questions that have been posted so far. So one of the first questions we want to answer is when will you be receiving this presentation? So in the coming week, I think the attendants will be receiving an email from us, including a link to the presentation where we'll be able to see both the presentation and all the marketing materials attached. The other question that has been asked is where will they be able to buy this film? So we have 4 different suppliers of tender frame across Asia Pacific, 3 based in China, 1 based in Southeast Asia. But we strongly encourage our customers to approach your DAO representative to facilitate in the application development, because we feel that's the best way to get a successful implementation of your package. And the next question, I think we will, questions about barriers have been very popular. So I think I will hand over to Dr. Yi, who will answer some of these questions.
Okay, thank you, Jason. Now, there's actually quite a lot of questions on barrier, so we really have to split it down in detail now. The first thing I would like to cover is the barrier properties of tender frame BOPE. Okay, now, tender frame BOPE, despite its numerous advantages, especially in terms of toughness, it is still basically a polyethylene material. So from our understanding of polyethylene material, it has very decent WVTR. However, in terms of the OTR, definitely cannot be compared to, for example, PT, BOPA, etc., etc., etc. So there is still a limitation of its barrier. But the good news is that BOPE, number one, it is metallizable. Okay, BOPE is metallizable. So as we all know, we are all in this field. Metallization helps to improve the WVTR as well as the OTR concurrently. Now, and when we are looking at barrier properties, right, we cannot also just look at tender frame BOPE. The lamination side or the lamination film can also assist in helping to achieve the desired barrier performance of your end users or brand owners. So that's another element that we really have to consider. So barrier films like BOPA-based barrier film or EVOH-based barrier film, or even the combination of both, can be used to enhance the barrier. But of course, when we put that, right, people will start to ask, hey, would this be recyclable? Now, not to worry, because like the latest advisory that was updated is that so long the amount of polar barrier materials like polyamide and EVOH is less than 5% of the overall, is considered to be fully recyclable. 10% or less is partially recyclable. So again, do not worry. DAO does have the necessary compatibilizers for you to recycle all these polar materials as well. Unfortunately, the retain, which is the compatibilizer, is not the focus for today. So again, we will strongly encourage you to approach your nearest representatives, either commercial, your account managers, or even your technical partner from DAO, so that we are able to give you the best information and again assist you in terms of application development. So in terms of coatings, right, it also can be done. So the key takeaway for tender frame BOP is you can treat it really like a PT or BOPA pre-replacement layer. Okay, so with this technology, the world is in your hands. So there is really a lot of opportunities for you to use this to move forward in terms of application development to meet your sustainability goals. So I will strongly encourage all of you, right, to actually connect with the DAO representative nearest to your country, and we'll connect and assist you from there. Okay, so the next question will be about the thickness, right? I do see this being popping out. So, why is tender frame BOP is about 35 microns, and then the comparison data we have is only 15 microns BOPA. Now, again, I must stress to you guys is that this one we are actually comparing commercially available films. As what my partner Jason has mentioned earlier, there's really 4 qualified suppliers in Asia Pacific, and we are able to obtain 35 microns films from them. Okay, so if we want to compare something, we can't get an ultra thin film, same thickness that you can get it available in the market, right? So we use market available films for comparison, and in fact, BOP is so tough, it is a different performance class compared to BOPE. So So with just a slight increase in thickness, right, we are able to meet toughness, and that is an extremely positive thing, so that we all can slowly move towards a monomaterial structure for improved recycling. Okay, so the next question about PAC Studios. Just to recap, in the presentation, right, there's actually there's actually about 3 main PAC studios in Asia Pacific, mainly Mumbai, Shanghai, and Singapore. Okay, so now in order for you to, if you really want to visit PAC Studios, no matter where you are, or you can actually visit the closest PAC Studios to you, what you need to do is just connect with your technical counterpart from Dow or the commercial counterpart from Dow, and definitely will be able to arrange for you to come over to your nearest PAC Studios. And in fact, if you want or you have the resource to visit a PAC Studios that is out of your country, that is also possible. So let me continue to screen the questions. Okay, now, how does BOPE compare to BOPP in properties? Okay, I'm not sure whether you have seen a slide which my partner Jason was talking about in terms of the performance. Okay, BOPP is clear. We all know that. BOPE, in terms of clarity, is not that far off, and it's in transparency. But the key difference will be the toughness. Now, people skilled, you work with BOPP every day, you feel the film, it's stiff, very stiff, and it gets torn easily, right? Now, but although BOPE in the video, it's mentioned that it is easy tear. But when we look at the 3D perspective, right, the film is actually very tough, especially in terms of puncture and dart drop compared to BOPP. And that is the key reason why BOP is able to perform so well and allow, as one of the case studies have demonstrated, a 1 liter pouch being dropped from a 2 meter height 6 times. The same pouch being dropped 6 times and it's able to survive. You do it to a BOPP based film, I will doubt that the resulting SUP will be able to survive that sort of intense dropping. So the key takeaway is really BOPE itself, right, can give you the toughness, but still allowing the ease of convenience for consumers due to its unique easy tear performance. Okay, but of course I do see another question about why BOPP and the recycling compared to BOPP versus BOPE. Okay, or wait, BOPP laminate to P film versus BOPE laminate to P film. There's a question there. Okay, so just to give you a guide is that fundamentally, if you are talking about recycling, BO, or I would say PP and PE, they are not compatible. Okay, they are fundamentally not compatible. So if you blend these two together, you will start to realize that there will be space separation. So from the naked eye, you will see as the film turning very hazy. So this actually is very detrimental to recycling because, right, the end resultant film will be weaker. But we all know if you go full PP, okay, we go full PP, the toughness of the whole pouch or package cannot be strong, and the sealing speed is also affected. And that's the reason why, after putting a lot of application development experience, right, we are actually putting a lot of effort to develop BOP based solutions. Okay, so let me screen the questions. Question: what is the difference between Singapore and Shanghai PAC Studios? Okay. Now if those who have been there, I'll be honest with you guys, the first thing you see is the size. Okay, the Shanghai Dow Center is really very big, but it houses a lot of other businesses of Dow. and because of the necessary the space they have, right? They actually have a lot more space to put a lot of instrumentation, and Shanghai PAC Studios also has the support of Dow core R&D team. So in fact, they have a lot of blown film lines, testing capabilities, right down to the fundamentals those that you see at the university. Now, in terms of PAC Studios Singapore, okay, we are very focused on application development. So our asset investment will also be slightly different. And that's the key reason in the presentation slide you have seen. We are able to have the pouch making line. We also have a prototype bloom film line. And of course, there'll be future investment into a commercial bloom film line as well. So if you are very interested, right, just connect to your nearest representative, and then I'm based in Singapore, so definitely we can have a nice chat if you happen to visit those Singapore PAC Studios. Okay, so the next question: how is the printability of BOPE, reverse surface printing, gravure? Now, if you look at the case studies that we have, you saw the white color pouch, slow pouch drop in the video with the Dow logo and confidential sample. That one is actually gravure reverse printed. Okay, and this clearly demonstrates the printability. Now, for surface printing wise, right, this is more on the ink formulation, because as you all know, if you are doing surface printing, there are already polyolefin based inks out there. It can be done. But if they are not UV curable, then you need to apply something to protect the ink. And that's the key why even today PET, right, they use reverse printed, because they do not need to apply that surface protection layer. So talk to your ink suppliers. Most of the ink suppliers already have those polyolefin inks for gravure, for flexo, right? And okay, depending on surface or reverse print, that's where we will start to work out the details for your respective application development. Okay. Now, next question. Can we reuse in-house material by recycling? Okay, that's a very good question. An excellent one, because right, the good thing about Tender Frame BOP is that Tender Frame BOP is PE, right? If it's PE, it's definitely recyclable with the PE recycle stream. So things like, when you make the laminate, use the side trimmings you get after you slit it to the right width, all these side trimmings, right, can be used. And if you look at the MI, right, of the BOP, Tender Frame BOP resin, it's 1.7. So meaning, once you take out all this scrap for your in-house production, you can actually take this scrap and recycle them. This is definitely not an issue. And I don't see any significant
Dr. E, for answering those technical questions. I'm afraid, and thank you for the audience for all of those questions. I'm afraid that this is all the time that we have today, and I hope that you all learned a great deal of information from the presentations. We would like to thank Dow for organizing this webinar in partnership with Ring Gear Events. Also, on the screen right now, you can see the contact information to Mr. Jason. So please write it down, because you can reach out and ask all those questions that haven't been answered today. You can write to Mr. Jason, and I'm sure that he will answer you them personally. So please contact him for all those questions that were not answered right now. Also, I would like to let you know that don't forget to register for the next DAO webinar that will be in about 2 weeks on July 16th on innovate solutions to polymer modification and recycling at 2 p.m. Singapore time. After we will close this webinar room, you will be actually directed to the registration page if you would like to do so now. So I would like to thank you all and see you all again in the next DAO webinar. Have a nice day. Goodbye.